indeterminate differences. If the limit as x approaches a of f of x is equal to infinity, and the limit as x approaches a of g of x is equal to infinity, then the limit as x approaches a of f of x minus g of x is called an indeterminate form of type infinity minus infinity. Again, there is a contest between f and g. Will the answer be infinity if f wins? Or will it be negative infinity, g wins? Or will they compromise on a finite number? To find out, we try to convert the difference into a quotient. So for instance, by using a common denominator or rationalization or factoring out a common factor, so that we have an indeterminate form of type 0 divided by 0 or infinity divided by infinity. Example 7, an indeterminate form of type infinity minus infinity. We're going to compute the limit as x approaches pi over 2 from the left of the secant of x minus the tangent of x. So the first thing we need to take a look at is that the secant of x approaches infinity and the tangent of x approaches infinity as x is approaching pi over 2 from the left. So now what we want to do is we want to take a look at this and write, okay, we want to find the limit as x is approaching pi over 2 from the left of the function secant x minus the tangent of x. So what we can do is we can rewrite this by using trig identities and then find a common denominator. So the next step of what we can do is we can rewrite this limit as x is approaching pi over 2 from the left. Well, what do we know about the secant of x? Well, we know that that is the same as 1 over the cosine of x. And we know the tangent of x is the same thing as the sine of x over the cosine of x. Okay, now we can find a common denominator. And so by adding these two together, we get 1 minus the sine of x in the numerator, and we're going to divide that by the cosine of x in the denominator. And so now we can start by using L'Hopital's rule. Because in a numerator and denominator, it is still indeterminate. Because as 1 minus the sine of x as x is approaching pi over 2 from the left is equal to 0. And likewise, cosine of pi over 2 from the left is also 0. So that's an indeterminate with 0 over 0. So now we want to find the limit using L'Hopital's rule now as x is approaching pi over 2 from the left. We take the derivative of the numerator. Negative sine of x becomes negative cosine of x. And the derivative of cosine of x is negative sine of x. So we know that that negative divided by that negative is going to make that a positive. So the limit as the cosine of pi over 2 from the left is equal to 0. And the limit as a sine of pi over 2 from the left is 1. So therefore we get 0 as our result. So what's also a good idea is, keep Desmos, available to you, or a graphing calculator, so that you can look at where the limits approach. So as the cosine of x is approaching pi over 2 from the left, you can see it gets to 0 over here. And as the sine of x, as it is approaching pi over 2 here, it is approaching the value of 1.